Hi everyone, Rhoda here with a JAC Capsule on logarithms. What is the relationship between exponentials and logarithms? Well, here's a basic exponential function. I have y equals a to the power of x. This is the simplest exponential function that I can write. A is the base, and that's just any positive number that I choose. That's called the base of the exponent. Now, that's really the function. You can think of the function as being a to the power of something. The something that we plug in is our input, and we usually write that as x. Then we'll calculate what that is. A to the power of x equals some number. That gives us an answer, which we can call our output, and that's usually written as y. If I wanted to flip this expression around and do the opposite, or the inverse, I would use the logarithm. I would have to use the logarithm with the same base as my original exponential expression. So here's my base of a, but because it's the inverse, the x and the y, or the input value and the output value, will get exchanged. That's what always happens with inverses. So my output of y from the left-hand side would now become my input, and the x that I plugged in on the left-hand side would now become my output. They get exchanged. That's how inverses work in general. So this is the inverse relationship between exponents and logarithms. For example, if I looked at the equation y equals 2 to the x, that's an exponential function. The inverse would be the logarithm with the same base, so base of 2. The x and the y's get exchanged. So whatever I plug in to 2 to the x, that now becomes the output for the logarithm, and whatever I get out as an answer for 2 to the x, that now becomes the input. Usually, though, we don't write it like this. Even though we understand that the x and the y's have to be exchanged, we're going to rewrite this as y equals log base 2 of x, just to respect the typical function notation. So it's more clear when we look at an example with numbers. If I choose a value for my input, if I say 2 to the 3, then I can calculate that. 2 times 2 times 2 is 8. This is an equation that I know is true. I could convert that into a logarithmic equation that I also know is true. So log base 2 is my logarithmic function. The input from before was 3. That's going to become the output now. And the output from before was 8. That becomes the input. So since I know that 2 to the 3 is equal to 8, I also know that log base 2 of 8 is equal to 3. That's how you can go between the two. And here it is written out as a formula that you might want to add to your notes somewhere, or you can check out the PDF version of these notes in the details on this video. Let's try this out. So here I have two columns. On the left-hand side, I'm writing exponential equations. On the right-hand side, I'm writing logarithmic equations. What I want to do is take whichever side has been filled in and convert that over to the other side. You might want to take a minute and try this yourself, and then pause the video when you're ready. I'm going to go straight through all three of these. So in the first one, I have a to the power of 0 is equal to 1. I know that's true. Anything to the power of 0 is going to give me 1. So that's a true statement. Let me convert it to a true statement about logarithms. I had base of a for the exponent, so my logarithm side also has base of a. Now the input and output get exchanged. So instead of saying a to the 0 equals 1, I can say log base a of 1 is equal to 0. And that's always true. That's a good thing for you to know. Log base anything of 1 will always be 0 because it's the same thing as saying a to the power of 0 is equal to 1. Next line. My left-hand side is not filled in this time. I have something on the right-hand side. On the right-hand side, it says ln of 1 is equal to question mark. So here, I'm actually trying to solve a problem. I'm trying to figure out what is the value of ln of 1. Now, remember that ln is just a notation for log base e. Log base e is so common that we don't want to write it over and over and over again. It gets its own special notation. So to convert that to an exponential, I write e to the power of something. Now again, my input and my output get swapped. On the right-hand side, I was plugging 1 into the logarithm. That's going to become the output for the exponential. And the output for the logarithm was question mark. I didn't know what it was. That's going to become the input for the exponential. Now, maybe that can help me find the answer. So if I don't remember what ln of 1 is equal to, I could just look on the left-hand side and remember, oh, that means I want to know e to the power of what would give me 1. And then hopefully you would say to yourself, well, e to the power of 0 gives me 1. And that's why the answer here is 0, which maybe you already noticed we figured out in the previous example anyway, that any logarithm of 1 is going to be 0 anyhow. Final example, again, it's filled in on the right-hand side. It says log base 5 of what is equal to -1. So here again, maybe you're actually struggling to find what that question mark is standing in for, and maybe it would be helpful to rethink it by writing it as an exponential equation. So switch the input and the output. -1 was the output on the right-hand side. It's going to become the input on the left-hand side. And same thing for the question mark. That was the input. It becomes the output. So I can convert this equation to an equivalent expression that says 5 to the -1 equals what? Well, I know how to solve that. 5 to the -1 is 1 over 5 to the 1. So it's 1 over 5. That means that my unknown value here is 1 over 5. That's how you can go back and forth between exponential and logarithmic equations, and sometimes it can help you figure out some unknown values. For more practice on this, check out the next video.